Hello there. In this example slide, we are going to understand what is an Ohm's law and how we can understand it. It is by means of an example. So you basically see that there is this tank indicated by a white cylinder. Inside the tank, we have some liquid, let's say, or a water, and then here at the bottom of this tank you have this small pipe in the gray. So the water is creating or exerting a pressure onto the pipe, and that water is coming out of the pipe, and it is shown as shown here. So we see that the resistance offered by this pipe is small enough, so we call it as a small r or small resistance. So for a given amount of pressure from the water, you have the water drops coming out of this pipe. So this water drops represents the current, let's say. So we are basically talking about an analogy between a mechanical and the electrical domain. So the water pressure is electrical voltage analogically. Pipe's resistance is indicated by R, and the droplets, water droplets coming out of the pipe represents the current. So you have the same flow in both of these diagrams. However, you see that there is a large amount of water here. That means you have a large amount of pressure exerted by the water. In electrical domain, we will say you have a large amount of applied voltage. And this is the case because in this case, we see that inside the pipe, there are some hair. So there is some blockages. So the water is not going to come out of the pipe easily, what you would see otherwise here without a hair. However, we see that the same flow, we are saying, showing here the same flow. It means in the event of some blockage, for example, here in the pipe, so in that case, the pipe is offering a large resistance. And if you want the same amount of flow coming out of the pipe, you have to exert a more pressure from the water. So you have a large quantity or amount of water filled in the tank. So that will have a large pressure, so that you will have a same amount of water coming here. So in electrical domain, how we understand here, for the large pressure, it means higher pressure, that means you will need to put higher voltage in order to get the same current flow for increased resistance offered by this pipe. So I hope you understood this analogy between a mechanical domain and the electrical domain. Here the pressure is a voltage, the pipe's resistance is a mechanical resistance is equivalent to electrical resistance, and the drops of the flow of the water coming out of the pipe is a current flow in the electrical circuit. So there are three primary equations by which we relate the Ohm's law, and we understand the Ohm's law, and we link voltage and the currents and the resistance to each other. So what we see, the first example here, the first formula is V equals to I times R, that is voltage is equal to current multiplied by the voltage. In second case, you see you can write I is equal to V over R. So it's basically you are taking the I in the denominator, not taking the r here in the denominator to the left hand side. So I is equal to V over R. So that's what I have written here. And the third possibility is you just say R, keep it here, and take I to the left side in the denominator. So R becomes V over I. So all these equations are related to each other, and they represent the Ohm's law in a linear equation. Okay, so as you can see now, there is simple schematic where we have a resistance indicated by R, and across the two pins of the resistor right here, we apply a voltage difference, a positive and the negative terminal. Obviously, the current will start flowing. It is coming out of the positive pin, and then it is passing through the resistor, and the current direction is entering to the negative pin, so making the loop close. So this is how the loop gets closed, and inside the loop you apply the Kirchhoff's voltage law, which gives you all these equations. So V is equal to I times R, I is equal to V over R is equal to V over I. So this is how you basically verify your voltages and the currents into the circuit. Okay. So I hope you found this model useful, talking about Ohm's law through the example. This is a mechanical analogy which we correlated with the electrical one. And stay tuned for more engaging content like this. Till then, wish you happy learning.